Some more impressions from the city of Graz. So welcome back to our symposium for hail mitigation here in Graz at the University for Applied Sciences, UNIUM. We are talking about technology, we are talking about chemistry and the new weapon, if I may say so, against hail. So we have now reached the second part of our program. In the morning we talked a lot about climate change and what it does to hailstorms, how much hailstorms will increase in frequency and intensity, and we have also talked already about hail mitigation flights. And now we will talk about research projects which tested silver iodide application in cloud seeding, and we will now talk about the future. Mr. Gruber from the University of Graz, welcome. The chemistry of hail mitigation. So much is changing at the moment. The threat is becoming larger, but also technology is changing, so there's a lot to expect. You have the floor. Well, I'm Christian Gruber. I'm a chemist and a chemical scientist, and I am doing research on hail mitigation, the chemical side of it. I'm happy to see a lot of people watching us online, and there are also experts among us, cloud seeding experts. So I think that there's a lot of international interest already. I would like to speak about chemistry a bit. I would like to talk about the history of the development. I would like to show data of our research and data from literature. So I will also quote other works. We are generally doing research in crystals, so we will look at silver iodide in its crystalline form. I would like to start with a short introduction and the chemical basis, and then I would like to explain our chemical analysis and some perspectives for hail mitigation. This picture has already been shown. In science, we don't always depend on prayers and weather crosses. We really need visions, but we also need hard scientific facts. So the field as such is quite complex and is interdisciplinary. So there are various fields that you need. You need toxicological and biological research, atmospheric chemistry is important. So it's important to analyze all these fields to understand what we are doing. This is an active field of research. If we look back at the 50s, this is the number of publications in this field. And so there was an increase in publications, and then in the 70s it was more or less stable. And now we can see that we have a rise in publications again. Why is that? Because, as we have already said, changes in catastrophe scenarios, there are more extreme weather events, so more research is necessary in this field. There's a lot of science fiction literature also on ice formation. Why did Kurt Vonnegut publish a book about forming ice at room temperature? This was kind of a mysterious link. The explanation is simple. Mr. Vonnegut had a brother, and they were both working for General Electric, an international company, very powerful. This is their headquarters, and they studied weather changes and how we can actually bring bring them about. So Bernhard Vonnegut, the brother of Kurt Vonnegut, tried to use silver iodide for cloud seeding in order to prevent formation of hail. So this dates back quite a while. At -5 to -20 degrees, they found it would be most efficient, and this ice chamber that we already talked about today already existed in the 50s, but technology was different at the time. So I would like to show you what they did to create the nuclei. So this was also linked to the US Army. So the US Army was interested also in this research. So there were already experiments with a small plane that flew in the 50s to try and produce snow. So it's always about crystalline precipitations, and we want to prevent hail in what we do. So this idea of the time was then industrialized. They used larger planes, they used propeller planes, and they flew to the clouds, and the first one was General Electric. And this is when cloud seeding really began. So seeding clouds with cloud alien substances in order to change them. What do I want to say if I talk about upscaling? This is actually a warplane which was then used for the peaceful mission of cloud seeding. So you can see the top of the cloud on the left picture, and they put numbers on the clouds to show where they injected the silver iodide to see what difference it makes. So there were already experiments to show that it does work, and then there was continuous research for a while, but the field didn't really grow as much as it does since we deal with climate change. In 2022, a very good publication was published about the technology, explaining how it works. We have already heard a lot of meteorology today, so this is not actually my expertise. We inject silver iodide into the clouds. This means we introduce a condensation nucleus, and the water crystallizes more quickly, forming smaller hailstones, and they can then melt until they reach the ground. So using silver iodide, we try to produce a sufficient amount of crystallizing nuclei so that we really have an effect in the clouds and on the hailstones in the clouds. In the ideal situation, the water will then just rain down as water or as snow or as soft hail. Our main goal always is to prevent serious hail, so we want to reduce damage. As we were talking about chemistry, we need to talk about silver iodide and acetone and why this is relevant. So the chemistry of silver iodide is simple. It's actually sodium chloride with a different composition. It's a light yellow salt, a microcrystalline powder. And this also occurs naturally. But the silver iodide that we use is not taken from natural resources. It is actually produced artificially. So it is It consists of iodide, and it has a strong convalent part, which means that it is less water solvable than sodium chloride, which means that the compound is reinforced. This is one of the most researched compounds for hail mitigation and cloud seeding in general, because it has a strong affinity with hexagonal snow crystals. You know, snow crystals which take different shapes, and the hexagonal is has a strong affinity to this chemical compound. So per gram of silver iodide, you can create 1,000 crystallization nuclei. Silver iodide usually decomposes itself by once it comes in contact with UV radiation. And then there is the combustion, the burning of acetone. So acetone is the substance we use to, so it's our solvent which we use to apply silver iodide. So this is the chemical equation. So we need acetone, oxygen, which occurs sufficiently in air, and then the product is carbon dioxide and water. So these are natural chemical compounds which occur naturally in nature. So if it's so we speak of an uncontrolled combustion if there's a lot of smoke and flame. This means that it's not optimized. The combustion process is not optimized. When it comes to the combustion of acetone, you know this substance. It's, for example, in nail polish erasers. We will have a short presentation later to see how exactly it works to burn these substances in our generators on the planes. Now I would like to explain our chemical analysis of these generators. So we have been continuously optimized our processes, but sometimes the supplier changes, sometimes the composition changes. So for example, Mr. Mündler already showed us mud within the combustion sludge within the combustion chambers, which can occur quite suddenly and which we have already observed. So here are a few pictures of residues that can occur in operations. This is a really big problem. So why does this occur? The solutions we use in order to apply silver iodide, we always have 3% silver iodide, 6% silver iodide. So this is the information we get from the suppliers. So why do we get different residues depending on the substance we use? Here, analytical chemistry can help us. Simple experiments showed us a lot of important things. For example, what happens if we just burn it in the laboratory? What happens if we just leave the solution? How will it develop? Or if we evaporate the acetone, why does the silver iodide sometimes become yellow and sometimes white? So there must be individual components that make this difference. The University of Graz, especially Mr. Gössler and Mr. Zanger, did research into this, and we used their information in order to improve the systems. So this analysis was done with mass spectrometers. You know this from the airport, where your bags are controlled for explosives. So there's a nuclear spin analysis where you can analyze the acetone. And the results are actually very interesting. I highlighted in yellow where you can see the differences. I didn't put in any company names. I am sure they will publish their results at a later point. You can see the amount of silver parts is not always the same. So for one solution, you can see a reduction of 1/3 in silver, and then there's solutions that contain less iodide, and then there's also additional substances. In order to combine silver iodide with acetone, you need natrium or sodium, different suppliers are using different methods. So you really need to look into which kind of silver iodide you need for your generator, because the conditions are not the same everywhere. So analyzing acetone also brought us different results. Acetone in its pure form is very expensive, so that would not be affordable. So companies seek different kinds of solutions. They add more or less water. You can see this in our tests where we left the solution to rest for 24 hours. Here you can see the changes in the solution. There is always there can always be impurities also in the compositions, which can also make a difference. So to sum up this chemical analysis, the elements are silver and iodide, which are found in the commercially available solutions, and then there is chloride, less silver iodide. In one composition we find other compounds which we will continue to analyze. And then there's the quantity of water, which is also relevant. You might ask why, because there's always water in clouds that contain hail, but there's a difference in whether the water was already present in the solution before or whether the silver iodide meets the water in the clouds. So a high quantity of water is not really an advantage, and this needs to be looked into more closely. So this is actually already almost the end of my presentation. You have seen that the number of publications has increased. But this needs to be differentiated. Basic research deals with topics that are more general, and then which we have not yet found solutions for. And applied science then works directly with, for example, hail mitigation to see how things can be put into practice. Networking is key in this context, and in hail mitigation we definitely haven't reached the end yet. We need to continue understanding the systems better and the chemistry better. We need to have more chemical analysis of the solutions before and after their applications, particle analysis. How many particles are there? How big are they? How do they need to be? What composition do they need to have to be efficient? And then there is an important question: how do I measure all this? There are in vitro experiments, in vitro tests, where we have controlled conditions and can check how much hail we could prevent and how many ice crystals are forming. We can think of the B-19 airplane in the 90s. Now we have newer generators, and we can measure again what is the most efficient system. There are many experts all over the world who are doing research on hail mitigation. So here we can really try to network. This is really a good basis for common projects. So what are our visions? What is the perspective for the future? The second 2 points are not really in the chemical field. So this is drones and artificial intelligence. Of course, that's an important field. But in principle, there's also the possibility to rethink completely what we do in hail mitigation. So this will be a process that might take decades. But today we speak of efficiency of generators. Maybe in 30 years we will talk about which bacteria have which efficiency in hail mitigation. But this is a vision which is in reach already. We have already heard a lot of about negative impacts. We don't want to talk about this in detail now, about biological particles in the air, but biological particles are actually present in the air. Those are natural, healthy microorganisms. The world needs these organisms. You can see a current Nature Scientific Report study where they found out which microorganisms are present in the world. So they analyzed which bacteria is more frequent in which parts of the world. What has this to do with hail mitigation and hail? In nature, and there is studies, very recent studies even, on this subject. These bacteria and biological particles favor the formation of hail. So bacteria with their surfaces and their crystalline form can be used as seeding nuclei. So this can be an interesting path to take in the future. Of course, this is still way down the road, but because we need to think about how we do it. Now we burn our solution, but we cannot do this with the bacteria. So we will need to think about how we apply the bacteria. But I think that biological elements like bacteria really have the potential to make us rethink over the coming decades how we can work in hail mitigation. They are natural, they are fully biologically degradable, and they are cheap. So thank you for your attention. We still have a few minutes for your question. Thank you, Mr. Gössler and Mr. Klaus Zahler of the Graz University for their chemical analysis, and Mr. Schaffner for his data for the generators. Thank you very much.
Christian Gruber, derweil einmal ist gut,
Thank
weil du wirst dann später
Christian
auch noch
Gruber.
Dazu etwas mehr sagen können.
You will have another presentation later. We will see if there are any questions. Of course, you still have the possibility to ask questions directly next to the live stream and at michael.kerner@gmx.at. I think the most fascinating in what you said was that everything we inject into the clouds will finally come back down to Earth. So, of course, there's criticism here if some people look into whether this could be harmful to our planet. So these are aspects to consider. Yes, of course, this is important. So that's also why I listed toxicology toxicology, which we need to imply in our research. So we have seen in studies that the concentration of silver iodide on the ground or in lakes and rivers is below the legal limit. So the concentration is so small that it is really that it really doesn't have any impact. It would be even better to have new substances, organic substances, which could have a great benefit if we use them. Yes, of course, they might have other effects, ethical. We need to have ethical considerations, biological considerations. There's a lot of questions. So, of course, we won't be bored in research. So there are no other questions for the moment. Thank you very much. And we will go on to our